Recording is on. There we go. Great. Okay, so I'm going to assume that you guys haven't looked at MiniScript or Mini Micro at all, and we're starting from square zero. Is that right?
That's right.
That is correct.
Okay.
Although I have seen that logo before, and it's mighty cute.
Thank you. Okay. Well, so there's really two pieces here. One is the MiniScript language itself, and then the other is Mini Micro, which is a sort of virtual home computer built on top of MiniScript. And I think I'm going to jump right into Mini Micro because that's really the more fun part of it. And I think my purpose this morning is just to sort of show you what it can do and give you a taste for it. But if you have any questions or want to dive deeper on anything, just let me know.
Okay.
So this is Mini Micro. It's running, within a window, and it's supposed to look sort of like an 80s style, Commodore 64 or something. But at the prompt here, I'm actually typing MiniScript code. Here's some basic MiniScript. And that's used also for accessing the disk. Unlike most systems, even back in the old days, disk operations would be DOS or ProDOS or something, and programming would be basic. In Mini Micro, it's all the same. So I can do, when I type dir, that's running a MiniScript function that gets the file list and displays it and pauses if there's more and stuff like that. Out of the box, Mini Micro has two disks, but this /user disk would be empty. But there's a /sys disk that is built into the virtual machine, and it's read-only, and it contains demos as well as some assets in the pics and sounds folder, some library code and lib, and some other stuff like startup.ms is the script that runs when the machine boots up, and it prints that welcome message and so forth. So if we were to go into demo, one gotcha here is because we're typing MiniScript code at the prompt, I have to put quotes around the arguments. If I just did cd demo, it's going to say demo is an undefined identifier. So with quotes, cd demo, here's some of the demos that are built in. And I'm not sure where to begin. Well, let's start with the first one, actually. So I can load AC2C. And if I wanted to view the code, I can just dump it to the screen with source. That's not terribly useful. Or I can use a built-in editor. Edit launches this graphical editor. At this point, I can use the mouse, and I can select, and I can copy and paste and all that stuff. But let's just run it. So AC2C is a little betting game, and you're betting whether the next card is going to be between the first two cards that you were dealt. So will the next card be between a 7 and a 10? Not too likely, so I'm going to make a small bet. Hey, but I actually won. Did you guys hear a cha-ching sound just now?
I did not.
Okay, so it's not. All right, so it's not transmitting sounds apparently with the screencast. But no big deal. Anyway, take my word for it. There was a sound. Mini Micro supports sound effects as well. Between 8 and a 9, that's actually impossible. But I'm going to bet everything because I'm not too smart, and then I totally broke. So this is a text-based game. The symbols you see here are just Unicode characters. The built-in font has a handful of non-ASCII characters in it for things like that. I can, clear the screen and get rid of all that. Oh, here's a better introductory example, actually. Let me load Countdown. This one actually is short enough to just list it to the screen. So you can see there's a for loop. It looks a lot like Python, a print, and a wait. This waits 1 second by default and then ends the loop. So when I run this, it does exactly what you'd probably expect. So this is, yeah.
For just one second.
Mm-hmm.
My screen has frozen and I don't know. Oh, okay, suddenly unfroze. Okay, never mind.
Huh, Bethany, were you seeing problems too?
Jitsi has intermittent problems. And this is, I don't know if either of you have looked at like the discussion that was happening in CodeBuddies meta around Zoom versus Jitsi.
Yeah.
But suffice to say, and I'm sure you two have been on other conferencing systems as well, the two-way communication with video and audio is not easy. And it also takes up a lot of bandwidth. And Jitsi being owned by Atlassian, but being open source, it's not as stable a platform as, say, Zoom, which is pretty flush with cache. So anyway.
All right. Yeah. Julie actually suggested that I should use Zoom, but I wanted to try Jitsi because I never used it before, and it's so easy having it embedded right in the page. But maybe next time I'll use Zoom instead.
Yeah.
All right. Well, bear with me and let me know if it's not updating for you, and we'll pause or whatever we need to do.
Certainly.
Okay. So that's basic text-based interfacing. Let's see. So Mini Micro actually has 8 display layers stacked on top of one another. Most of them right now are transparent, which is to say they're just off. But you can set any display mode or any of those 8 layers to any of several modes. There's a text mode, which is what we're looking at here, pixel graphics, tile graphics, and sprites. So those are the available modes. And by default, there's a layer already set up for graphics. It just happens to be transparent. But I can do, for example, GFX, which is a reference to that default graphics layer. I don't know, fill oval, and give it the coordinates. Oops. It's called fill ellipse, not fill oval. I was being pedantic when I chose the API name. Yeah, it's technically not an oval because ovals have straight sides. And different colors, whatever. And you can see that this graphics layer is behind the text layer, and the text layer by default is got a transparent background, so you can see through the text to the graphics layer. And basically, that's the big idea with these 8 layers: is any of them can be transparent in places that you want them to be, so that you can stack them up however you need to make a game or demo or whatever.
I really like, though, that the text is transparent by default, because kind of figuring out things like transparency in layers is something I think people new to programming struggle really hard with. Like, I watch a lot of people with CSS and HTML struggle with that.
Yeah, so I tried to set up all the defaults so that it would be, fairly sensible right out of the box. So out of the box, you can do text, graphics, and sprites, and they're all transparent in ways that you would probably want.
That's awesome.
Yeah, but for example, we could do text.back color equals color dot purple, and now any printing gets this purple background, which you can see is not transparent. So now it's covering up the graphics layer behind it.
So can you set opacity on colors, or is that a little bit?
No, you can do that. The colors are actually strings. So when I say color.purple, that's just a map to an HTML color code. But I could put in something like, I don't know, 444400, and then half transparent. And now, okay, it's a little funny looking because the text cells overlap. I've actually never tried that before, so I might want to see if I can do something about that. But yeah, that works for all colors.
Cool.
All right, let me put that back to clear because I don't actually like a background color in my text most of the time. But yeah, you can see here color is just a map. And maps in MiniScript are just like maps in Python. They're key value pairs.
Nice.
And similar syntax as well. So let's actually clear all displays and look again at demos, find some more fun stuff. I don't know how well, I can't think and type at the same time apparently. I don't know how well Jitsi is going to keep up with an animation, but let's just try. Oh, geez, I'm terrible at this. You can up arrow to go to previous commands, just like, at a Unix command line or something. Wow, I really am bad at this. There we go. Anyway, this is Flappy Bat. This is using sprites. You guys probably want to look at the code because you're programmers. So we'll do a real quick whirlwind tour through the code. Here I'm loading a couple of sound effects off the system assets. You can also create sounds on the fly by specifying frequency and a bunch of other stuff. Here I'm loading images, so file.loadImage gets an image from disk. I'm setting up a display for sprites, although that's actually the default anyway, but just to make sure I do it in code. Sprites is a built-in class, but I'm adding properties. So these things like dy and frame and next frame time, these are not standard sprite properties. These are properties I'm adding to my particular sprite instance. And then here's where I set the image. So basically, these are the key bits of a sprite: the image, the x, and the y position. There's also scale and rotation and stuff that I'm not using. I have an update method here. This gets called on every frame. It just handles flapping and the physics of the bat. Here I made I made a class to represent sprites. So here's how you make a class in MiniScript. It's just an empty map, or a map that derives from some other map, and then you start adding properties and methods to it.
That's interesting. So that looks very much like the way you would do a struct in, say, the Go programming language.
Okay, I haven't learned Go, but I can believe it. Yeah, it's instance-based object-oriented programming. So a map is a class if you think of it as a class, and it's an instance if you think of it as an instance. But any map can derive from another map, and when we do lookup, we walk the is-a chain until we find a match.
Oh, cool.
And that's basically it. And there's a couple of other niceties, like when you call a function without syntax, it gets a self identifier, which is the object you called it on. And then there's also a super identifier, which is a reference to the the superclass map. Anyway, so this is all detail, 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 and we'll go down to here. This is the main loop. And there's nothing particularly shocking here. This is doing the continuous scrolling function to handle the keys and so forth. Yield is a special method in Mini Micro that waits until the next frame. So it runs at 60 frames per second. So this will wait the rest of the 60th of a frame so that you can get consistent timing.
That's really interesting. So in Python, yield is used, of course, in a generator and waits for a next call. And so you are using kind of that same idea, except that the next call is coming from the key frame or the frame.
Yeah,
chain.
sort of the host machine. Right. Right.
Interesting.
Yeah. That's hard to read. It's clear. Okay, so what else is fun to look at here? Here's another sprite game. I won't belabor this because they're technically basically the same thing. But this is well, that's embarrassing. Always when you're doing a demo. Line 52.
I was actually going to poke you at one point in the CodeBuddies Slack, because I went back to try to play that game and it wasn't playing, but I assumed you were just, you were playing around with stuff, and so
I must. Let's see. Syspix block. I bet I've moved where those pictures live. So let's look. It's looking for /syspix block and then blank 2, 3, or 4. So let's look for that. Actually, was it? I've forgotten the syntax for this. I hardly ever use this function. No, let me just do this. Okay, yeah, syspix. So that's where we are. Block 2, block 3, block 4. That should work. One nice thing about having this sort of environment is that when I quit, all my variables that were defined by the program are still defined. So I could look at platform images and see what's in there. I hope you guys don't mind. I think this is a useful exercise.
Yeah, no, I think this is really cool. I know it's totally nerve-wracking to be on the other side of this, but I find it fascinating to watch people debug and to talk about their programs like this.
Yeah, okay. So our images look okay to me. Let's just check each one, because it's a little hard when they're all glommed together like that. Yeah, those all look fine. So why is it saying that it can't find width on line 52? Let's look one more time at that line. Self.image.width. That would be the case if the image never got assigned. Maybe. Is that possible? I swear this worked last time I ran it, but let's see. So platform's a sprite. It's got a config. It sets the platform images. We'll put in a check here. We can just say not, actually. And you know what? Let's just print that always. No, better yet, we'll do it here. I'm thinking of checking whether it actually has this. That's not going to work if the image is null, though. Tell you what. I think the easiest way to get to the, or fastest way to get to the bottom of this is just print the image here. Okay. Those all look like valid images to me. And they all have a width property.
Oh, and now the emoji's moving. Oh, except there's a type error now. Huh.
No, that's the same one. It's the same
That's
error
the
we were
same
getting
one.
before.
Okay.
Yeah, he was always moving until I tried to jump. And then once he's falling, we were looking for platforms that that it could hit, and that's when we get the error. All right, we'll get to the bottom of this. I can't believe that this is going to conquer us. All right.
I'm sorry, I interrupted.
No, it's fine. I'm going to try and think out loud as I do this so that you guys can hear my thought process, but please feel free to jump in if you have any ideas. We're going to say if self.image equals null, then print if self., let's see, we'll say if not, self.image.has index width, then print no width. And if neither of those prints, then it should work. So image is null. Okay. So somehow we're getting a platform with a null image. But on startup, we're not seeing that. So it's really puzzling. Let's see, here's where we add the platforms. We make a new platform, we call config, we push it on our platforms. Let's check at this point.
You took the words right out of my mouth.
Yeah.
Maybe something would have missed with the push. Maybe something would have missed with the sizes. Like maybe the sizes are being set some like too small or too big or parameters off.
That's interesting. Yeah. We were definitely using self. Like if we'd forgotten to use self here, then things would go wonky for sure. But since we are, it can't be affected by global variables or anything like that. We're only adding 4 platforms, and the sizes are 2, 3, and 4. So still stumped, but let's see if we gather more clues. Oh, I should have paid more attention at the beginning. Null image and add platform. Hey. So this is relevant.
Also, I'm hearing the sad mochi sound, which is really cute. By the
good.
way.
So the sounds are coming.
Yeah, I'm hearing you too.
All right, great. Okay, I'm sorry. I'm looking for the platform. It's up here. Add platform. Okay. So if pimage equals null, after we call config, then what in the world happens? Because we're checking. Oh, look, we're not using self here.
Oh.
How did that ever work?
Ooh. Oh,
That
wow.
would explain it.
Oh, wow. And now that you see it, I'm seeing it everywhere, but like.
I think that I originally wrote it not using oop, and then I thought I should make this a class, but I can't believe I didn't test it after doing that. This one's okay, because here, this is a global function whose job it is to create a new platform.
Yeah, yeah. So that one's not attached.
Yep, and this one looks okay. Yeah. Hey, look, we have platforms now.
Oh.
I love this game.
Yeah.
I you fixed it. Now I can go play it.
Well, yeah, I'm gonna have to go upload a new build to the web with a fix. But wow, I guess this was a really useful exercise. And I'll just jump to my death now. All right, interesting.
But what was also really cool to me was that it felt like, I mean, I know you're the creator of this and you wrote this program, but it also felt like debugging was pretty straightforward and pretty smooth. Like the code was, the game is fairly complicated looking, at least when you play it, but the code wasn't so complicated that you couldn't kind of debug it.
Yeah, like we zeroed in on the right area pretty quickly.
Yeah.
Yeah, I mean, and in a way, the debugging is crude, right? There's no stepping through the code here with an IDE, but on the other hand, you've got this tight connection, where you can just inspect variables after the program is stopped and things like that.
Yeah.
And you can print right on top of the graphics display. So in a way, it's kind of easy.
Yeah.
All right, that was a good exercise. Now, if I tried to save it, I haven't tried this before, but it should tell me. It should have told me it can't do that because it's a read-only disk. So I would need to give it a different path. Oops. So I'm going to make a note to myself over here that I need to check error messages when saving to a read-only volume. I should point out this is version 0.4. So yeah, there's still some issues. But it's evolving rapidly. I think in another month or maybe two, it should really be ready for real users. Okay, so let's see what else we've got going on. Oh, we're still in syspics. Let's go back up, down to demo. Oh, here's a fun one. This one.
I saw the graphics for that. I haven't played it though.
Yeah, so this demonstrates tiles, and you're just trying to trap the Wumpus, and he'll try to get away. And once you kind of learn the way of it, it's not that hard, but at first it seems like it's impossible. And of course, now that I say that, is he going to get away? The trick is you have to go way out in front of him and start constructing these walls so that you can lock him in. Oh, see, he got away. Dang it.
Nice.
Anyway, so this is using a sprite layer, a tile layer, and a text layer, of course.
So what's the algorithm for the movement calculation?
It's A star. So I have a function to get all the neighbors of a particular column and row, and this is a little trickier than it would be on a rectangular grid. You have to consider whether you're in an even or odd row. I have a function to calculate. Oh, I'm sorry. I thought about using A star, but in the end I didn't. Instead, I'm doing a flood fill. So I start with, you know what? I can show this because I left some commented out debugging code here.
Oh, cool.
Yeah. So let me run this and then explain it. So let's say I just click here. Okay. So these circles represent how far each cell is from the edge. And so I start by just assigning 0 to all the outside cells, and then I recursively assign, for each neighboring cell, it's distance is one more than the neighbor. But obviously there's a check where you never say it's longer than some value it already has. So it just fills from the outside in, and then the Wumpus just walks that gradient. He steps to the neighbor that is closest to the edge.
Huh.
Yeah, so you can see when I start making a real wall here that some of these blocks get pretty far from the edge.
But what's so cool about that behavior, if you don't know what's going on with the calculation, is that it appears that the Wumpus is moving away from your wall, right? You're chasing the Wumpus, but it's just making a calculation in any direction of like how to get to the lowest number.
Yep. Yeah, it seems like he's really clever, but he's really just walking the gradient.
Is this a fairly typical method for evading or seeking?
Yeah, I would say that the more typical algorithm is A star, which for a second is what I thought I'd done. Are you familiar with it?
No, I'm not.
Okay, A star is a search. It's just best first search. So if I were to start here and I'm trying to find a particular goal, A star works best when you have a certain goal. Say I'm trying to get the Wumpus from here to here. A greedy search would always step in the closest direction, and then it would end up, possibly going the wrong way before it concludes it needs to come backtrack and get to the goal. A breadth first search would try, all the closest spots, and then all the distance 2 spots and all the distance 3 spots, and it would find the shortest path to the goal, but it's not very efficient. A star is a best first search, so it keeps track of, for all of the spots it's considered, how expensive it was to get there. So in this case, how many moves it took to get there. And then it considers the neighbors of those moves that are cheapest. So it's looking for, it considers places that are closest to the goal, but also cheapest to get to. And it'll pretty quickly expand, not too many nodes before it finds the shortest path to the goal. But in this case, I didn't use A star for 2 reasons. One, I want people to look at this code and be able to, have a chance of understanding what it's doing. And if you haven't seen it before, A star looks pretty mysterious. And 2, there's so many goals. Any edge space here is a perfectly valid goal for the Wumpus, and that makes it actually pretty hard to use A star. You'd have to compute the distance from any point you're considering to the closest edge, and it just gets kind of thorny. So this flood fill method, upon reflection, was an easier solution. All right.
Thank you for showing us that. Having the circles visually. I don't know if you're doing tutorials or anything else like that in connection to this, but that thought process and those visuals to me are really valuable. Like if I were to go and make a similar puzzle or a similar grid, it would be very cool to see those steps.
Yeah, thank you. One of the features I'm going to be adding this week is the ability to draw text into a graphics layer. And once I have that, I might redo that so that instead of circles, I actually draw the distance as a number. That might make it even better for understanding what's going on.
Yeah, because you see the numbers, you see the distance.
Yeah, exactly. Okay, I think there's one more demo for today, unless you guys want more. I've got more time, but let me load up. It's not in here. I haven't put it in the system disk yet. Yeah, let me load tic-tac-toe.
Yay! I was hoping you'd go over tic-tac-toe since I've recently done a tic-tac-toe.
Yep, that's what I did. So this is using a simple heuristic algorithm to decide where to play. I think it's what your code was doing too. That kind of inspired me. So we'll go through this real quick.
Yeah.
I'm loading O and X pictures. I'm keeping the board positions in a list, a linear list rather than a 2D array, because it just seemed easier to deal with in the code. So I mapped array positions or list positions to map, the board this way.
Mm-hmm.
And then here's a function to check if we have a winner, and it's just, checking all the different cases, columns, rows, diagonal.
So quick question for you.
Yeah.
That is excellent, but I do want to know if you are going to implement or have implemented like slicing for lists.
Oh yeah, it does have slicing.
Excuse me, sorry.
But it's not obvious to me how slicing would have helped.
I'll show you later offline.
Okay.
I went and did slicing for these results using Python. Some of them require a start, stop, step.
Mm-hmm.
I found it easier to read, but this is also really clear too. So.
Okay, all right, I want to look at that. Yeah, but yes, list slicing in MiniScript is pretty much just like slicing in Python.
Cool.
When I was designing MiniScript, I tried to steal the best ideas from a lot of different languages, and you can definitely see the Python influence in it. So here's functions to get the column and row for a position number. Function to draw a box, it's just using the graphics commands to draw some rectangles, and to draw a mark, which is an X or an O. Here's a little function that gets a list of empty spaces. Now in Python, you could probably do this with map or reduce or something. I don't have those built into MiniScript, so I use a little for loop.
And I used a little for loop too. I did not use map or reduce. I tend not to. I tend to do the same thing here for clarity's sake.
Yeah, map and reduce are very concise, but they're not obvious to beginners especially, are they?
No, they aren't, and they are not, at least in Python, they're punished a little bit in their efficiency because they have to run in the Python interpreter. Whereas if you use like a comprehension sort of thing to do your map or a plain loop, you can get efficiencies because some of that gets pushed to the C level as opposed to running in the interpreter. So okay,
that's interesting.
Yeah.
All right. So then to get the computer move, it's based on this would win method that hypothetically says would this move win, and I do that just by cloning the array list. And I know this is a little different. In Python, you could just do it like this.
Yeah.
But in MiniScript right now, at least, you have to do it like this. And then we set the position, as specified, and check whether there's a winner. And so get computer move is just doing these heuristics. Always take a win if there's one available, block a player's win, and if neither of those applies, then I'm just having it return at random. This is a random move because I shuffled the list right here. And that's pretty much it.
So available at 0 is, I don't see you calling a random here.
Right. Here's the randomness. I shuffled the available
shuffle.
list.
Got it. Okay.
Yeah, I don't think Python has a built-in shuffle, but
no, that's cool.
Yeah, MiniScript does. It's got shuffle and sort. So that's pretty much it. I mean, handling clicks is all pretty obvious. And then here's the main loop. While we don't have a winner and there's still empty spaces, handle a click and check for the escape key. So that's pretty much it.
So for click handling, which I have to confess I'm terrible at.
Yeah.
How do you attach? Where are you attaching the handle? Are you attaching the handle to the board, or is it done automatically because it's running in this machine, and so it's tracking the click for anything inside the machine?
I think it's less complicated than you're imagining.
Okay.
There's no event pump by default.
Okay.
So I've got my main loop here that explicitly checks for the mouse button to be pressed. And when it is, then it calls handle click. And all handle click does, this is a global method, it checks the mouse position and does a little bit of math to figure out the column and row that you clicked on. And that's how all of the games and demos work. So obviously I've programmed in a lot of event-driven environments, and if you're making a GUI app, I get why that's really handy, but I think, especially for beginners, something like this is a lot simpler because there's no magic to it. There's nothing going on behind the scenes.
Well, and it's really nice because it can get people. I'm sorry, I interrupted you. I'll stop. Go.
No, it wasn't me. Were you saying something, Julian?
No, I just said,
Okay. Well, go ahead, Beth.
Oh, I was just going to say that one of the things that I had to do mentally when I was walking through this, which is strange, but because I've done click events in JavaScript, but when I was doing it in Python, I had to walk my brain through these steps. And so I was going to say what makes this really nice is you've constrained it so that someone can get used to the idea that there's this thing called a click, and your code has to handle the click, and they can wrap their minds around that and kind of grow outward from there. For the whole notion of listeners and other things that get more and more complicated as you do in GUI. So this is really nice,
Yeah. In fact, let me show a different one. Somewhere I've got a little drawing demo. That might be in Sys. I should probably clear that off. Yeah, Scribble. Because this is an even simpler demonstration of mouse interaction. Might make it clear. So first, let me show you what it does. Whoops, I meant to say run. So it's just drawing wherever I click the mouse, and the right mouse button changes the color.
Oh, that's really cool. Yeah.
Yeah, so let's look at this, because this is a pretty short program. I mean, the only reason the set color function is so complicated is because I'm also printing the name of the color at the top of the screen. So if you ignore that, here's basically the program. And it just says, if mouse button, which means the button is pressed, then do a graphics line. And then here's the check for the right mouse button, which sets the next color. And that's it. So there's really no events. You're just checking the state of the mouse. And you can do the same thing with the keyboard. There is an input buffer, of course, and you can pull key presses off of that, but you can also just check for any key to be pressed and do something with it, which is how most of the games work.
So you could do a little maze runner, and you could potentially do not only a maze runner, but a runner that backs up because you've got that buffer. Nice.
Yeah. Yeah, and that's actually why a lot of my programs end with key.clear. This clears the keyboard buffer because otherwise, if I've been checking with key pressed, oh yeah, here's an example of how you check whether a key is pressed. That doesn't actually swallow the input. It leaves it in the buffer. So then when you exited the program, you'd get like all those keys pressed, like spewing to the command line.
Yeah, so you need to clear it. Yeah.
We clear it. Yeah. Yeah, so I think at this point, you guys have seen pretty much everything there is to see. There's a little bit more with sounds we could delve into, but that's not too exciting. You guys have any questions before we quit?
Is there a way to export or compile or some way move games or scripts that you've created here?
Yeah. To somewhere else?
Yeah.
Okay, yeah, there's two things. The easy way is, in the editor, you can select all and copy, and then just paste that into something in your favorite text editor. And pasting works the same way. So you can copy and paste between the host environment. Only if you download the app. There's a web version of this, which has most of the same things. This is what you were using when you tried this before, Bethany. But because of limitations of WebGL, we can't save files and we can't copy and paste. So this is really this is kind of like the store edition, at Kmart, the demo models that you can play with, but you can't save your own stuff on them. So that's one way. The other way is there's an export command, which I haven't used in a little while. So. Oh yeah, you just say file export path. So for example, if I wanted to export one of these programs, I could file.export sunset.ms, and this works for images and sounds and then everything to it. It's a file operation. It just asks me where do I want to save it, and then it writes it out to that file. And there's a file.import that does the opposite. So this is how you would get your own assets onto your user disk. Your own images and sounds and things like that. At least it's one way. The other way is your user disk is actually just a zip file. So you could unzip that and fuse all of its contents with a file hierarchy and everything to your real disk, and then you do whatever you want with it. Zip it back up and call it user.minidisk. I should show that, and that's this file right here, and that's the user disk within Mini Micro.
So I could ostensibly put that under version control and make myself a repo if I wanted to.
Yeah. Yeah, in fact, if you're going to do that and you're serious about it, you'd probably set up a script to unzip this thing into your repo working copy, and then do the opposite. Go from your repo working copy to a zip file for use here. And if you, and then you go through that process every time you sit down to work, and you'd have all of your files, not just as a binary file, but as the individual text files and stuff. I can show you what that looks like. But because it doesn't end in .zip, I've got to use a terminal. So let me just do this real quick. Okay, so here's these files that we were looking at before, and I have a, oh, it's asking if I want to replace it. Sure. There we go. So there's the whole contents of my user.minidisk, including images and .ms file. This is one of my standard test images. It's a transparent GIF. And these MS files are just text files. Again, because the extension Finder doesn't know how to preview them, but I can drag them into my favorite text editor, and all the source code is there.
Very cool.
Yeah. The other thing I want to point out, in case you haven't already seen it, is our try it interface, which, if you make the window wide enough, this gets side-by-side code here, output here, and you can run code right from within your browser. And it can even take input and do weights and things.
That is really awesome.
Yeah, it's pretty slick. So when you just want to play around with the language itself and not all of that sprites and sounds and stuff that Mini Micro provides, this is the quickest way to do it. And I've put a fair amount of effort into a tutorial here that, for a complete newbie, starts you with print 1, 2, 3, and then teaches you about numbers and variables and functions and all that stuff.
That is sweet.
Yeah. All right.
Thank you very much.
Yeah, this was fun. This is my first Hangout, and thank you for joining me on it. I had a lot of fun too.
Yay.
Great.
All right.
Talk to you guys again.
Okay, bye.